Hello students, welcome to Inside Physics. Today we will do some more problems on JEE mains in current electricity topic. Here is the one. The actual value of resistance R shown in figure is 30 ohms. This is measured in an experiment as shown using the standard formula R is equal to V by I. This is from Ohm's law, where V and I are the readings of the voltmeter and ammeter respectively. If the measured value of R is 5% less than this actual value, then the internal resistance of the voltmeter is. See here, you understand the problem. There is a resistance R given in this circuit which is 30 ohms already given. So when it is connected in a circuit and measured as per Ohm's law, this resistance is actually come out to be 5% less than 30 ohms. So the resistance measured as per the experiment with this formula, what we get? R is equal to 30 ohms means if 5% less than 30 ohms means R experimental value is 30 minus 5 by 100 into 30, which comes out to be 28.5 ohms. This is the resistance of the experiment, and when voltmeter and ammeter are connected, the readings of voltmeter and ammeter are also noted as V and I. So here, what is the internal resistance of the voltmeter? That is the question. If this is the internal resistance RV of voltmeter, if you observe this diagram, this and this are connected in parallel. So the resultant of these two parallel connected resistances, RV is the internal resistance of voltmeter and this is the actual given resistor. So the parallel connection gives a resultant of, so what is the resultant? We can say 1 by R. This is, you can say RE, because this is the resultant value. R is 5% less. Measured value of R is 5% less. So we can take RE, this one. And the parallel formula, parallelly connected resistors having a resultant resistance of, and this is RV. Okay, now we need to find RV here. So applying this formula, what we get? We need to find RV here. So 1 by RE is equal to R into RV. This as comes to be RV plus R. So this implies RE is equal to RV into R by RV plus R. So in those values we can substitute and find out RV. Right. We will substitute the values in this formula. For that, we will consider this one as RE 28.5, and what is RV? We need to find the voltmeter resistance, internal resistance of the voltmeter, and R is 30 ohms already given here, 30 plus RV. So if you simplify this equation, and you can easily get the final value. That is a simple mathematical solution which we can do easily. So the final value after calculating, we will get RV is equal to 570 ohms. RV is equal to 570 ohms. So you can simplify this one by taking these values to left side, and the equation needs to be simplified mathematically. The final value will be RV is equal to 570 ohms. So we'll move to the next problem. Now we see the second problem. A resistive network shown below is connected to a DC source of 16 volts. The power consumed by the network is 4 watts. The value of R is, here this is the circuit. This is the resistive circuit, means there are so many resistors connected in this way. So if you consider this as a circuit, we need to calculate what is the value of R here. What is the data given? It is the DC source connected to the circuit is of 16 volts. This is the DC power supply. So this power, when it is going through the circuit, see, this voltage produces a current flow in the circuit, and 4 watts is consumed by this total network. Then what is the value of R? How to approach this kind of problems means, if you understand this circuit, this you can easily say, if this is considered as part A and this as part B, which are connected in parallel, you can easily understand the resistors 4R and this resistor another 4R are connected in parallel. So this part A is converted into a single resistor by calculating the equivalent resistance of these two resistors, and part B is also taken into consideration by calculating the equivalent resistance of these two resistors connected in parallel. So we will go one by one. RA, equivalent resistance of these two resistors. So here, when the resistors are connected in parallel, what is the effective resistance means? If RA is the effective resistance, we can write it as 1 by 4R plus 1 by 4R. So we need to take the LCM 4R here, and this is 1 plus 1. LCM of this, and we can take this into this form. Now this becomes 2 by 4R. So 1 by RA is equivalent to, this 2 times will be cancelled. This is 1 by 2R. So RA is equivalent to 2R. Now we will go to part B and we will calculate the effective resistance which are connected in parallel. Here I am writing for 1 by RB, that means effective resistance of this part. Again I will write 1 by 6R plus 1 by 12R. So this is the way to calculate the effective resistance when the two resistors are connected in parallel. So here 1 by RB is equal to, LCM of these two will become 12R, and this will become 2 plus 1. Okay, so this can be written as 3 by 12R, that means 1 by 4R. This is B. Now this, from this we can write, so 1 by RB is equal to 1 by 4R. From this we can write RB is equal to 4R. Okay. So RA, this part has come out as the effective resistance with 2R, and this part where parallelly connected two resistors become single resistor with effective resistance 4R. So how this circuit will be rewritten in the form. So if you see, we can write this circuit into 4 resistors which are connected in series. So the diagram, this circuit can be rewritten like this. RA, this part is equivalent to 2R. This is R already given. This part B is equivalent to 4R. This is 4R. And this last part is given in the circuit. This is 16 volts DC supply. So here I will write RA is equal to 2R. So with this data, we will, now our aim is to calculate the R value. So here if you observe, this 4 resistors are connected in series. So what is the effective resistance of the resistors which are connected in series? So the effective resistance will be R1 plus R2 plus R3 plus R4. So all the resistors are multiplied, added 2R plus R plus 4R plus R. So how much this will become? 8R. Okay, 8R. So the total resistance of this circuit, effective resistance, has now come to be as 8R. So this total resistance is considered to be 8R. Now we can remove this. So our aim is to calculate the R value. What is the data given? The power consumed by the network is 4 watts. So we need to have a relation between the power and the potential electric voltage supplied by the DC power supply and the resistance. If you observe the power and the relation between the potential and resistance, you can write it as E square by R, or in sometimes we can write it in this way also, V square by R. So what is the power? 4 watts. This is equal to voltage supply is 16. That means V square 16 into 16. But what is the effective resistance? In R we must write RE, that is this value. So 8R. Okay. So by this we can write R is equal to 16 into 16 by 8 into 4. So now we can get the R value from here. 4 fours and this is 8 twos. So 8 ohms is the resistance, R value here. In this diagram, when we are asked to calculate the R value, which has come to be 8 ohms. So this is how we need to approach this kind of circuit problems. We will go to the next problem. Now we will see the third problem. In a Wheatstone bridge, which is given in the figure, resistances P and Q are approximately equal. When R is equal to 400 ohms, the bridge is balanced. On interchanging P and Q, the value of R for balance is 405. The value of the resistance X is close to. You can see options A, B, C, D. Now we need to find the X value based on the given data. We know that Wheatstone bridge is an electrical circuit with a galvanometer and 4 resistors and a power supply, DC power supply, and a plug key. So here, what is the balancing condition of the Wheatstone bridge? We can write P by R. P by R is equal to Q by X. This is the condition, balancing condition of the Wheatstone bridge, which we have derived in our previous videos. You can check the derivation of Wheatstone bridge, how it was arrived. Now here what is said, P and Q are approximately equal, then at the balancing the R value is 400. So this implies we can write P by 400 is equal to Q by X. That implies P is equal to 400 into Q by X. So in the second part, what is given? On interchanging P and Q. So the resistors are interchanged. So we can write here this as Q and this as P. After interchanging, the R value at the balancing condition is 405 ohms. So for the second part, which is given in the problem, we can write Q by R is equal to P by X. So here what is the value of R given? Q by 405 is equal to P by X. So here you can observe P value 400 Q by X. So we will substitute the P value from the first part in this right hand side, and we will get 400 Q by X, and here also there is an X which becomes X square. So see, here I substituted P by taking the value of P as 400 Q by X. So when you substitute the value of P, this equation becomes in this way. So Q and Q will be getting cancelled. Now X square is equal to 400 into 405. So we can write like this. This implies X value will become root of 400 into 405. So when you are simplifying this by using the square root method or calculator, you can get the value as 402.5 ohms. So finally we have derived the X value. So this is the method that will be used while doing a problem on Wheatstone bridge. You must know how to write the balancing condition. See, balancing condition means here the current flowing in the upper junction and the lower junction, both the currents will be equal, and the galvanometer will show a null deflection at the balancing condition. So for the diagram we can write these two are the balancing conditions. Okay. So by this X value has come out to be 402.5 ohms. We'll move to the next problem. Now we will see the fourth problem. The number density of electrons in a copper conductor estimated in is 8.5 into 10 to the power 28 per meter cube. That means in a copper wire there are this many electrons, 8.5 in 10 to the power 28 per meter cube. That means per unit volume. So the question is, how long does an electron take to drift from one end of the wire 3 meters long to its other end? So the wire is 3 meters long, and the question is how long an electron will take to move from one end to other end. Generally, electrons will move in a conductor because of potential difference between the two ends, and the electron moves from higher potential to lower potential. So, what is the data given? The area of cross section of the wire is 2 into 10 to the power of minus 6 meters square, and it is carrying a current of 3 amperes. So, the data we have is number of electrons is equal to 8.5 into 10 to the power of 28, and what else, the length of the wire is 3 meters, and the area of cross section of the wire is given as 2 into 10 to the power of minus 6 meters, and the current carrying in the wire is 3 amperes. This is the data which is given in the problem. So how to calculate the time taken for an electron to move from one end to the other end? We know that time is equal to distance by velocity. We know from the equations of motion, distance, velocity, time have a relation like time taken is equal to distance traveled by velocity. So here, what is the distance traveled is nothing but one end to the other end of the wire, which is 3 meters, and this V is of the electron, velocity of the electron. So electron will travel with a velocity called drift velocity across a conductor where there is a potential difference. Drift velocity is a constant velocity with which the electron will move, and the collisions, when electron is moving across a conductor, it will collide with the atoms or ions present in the material, and actually the acceleration of the electron is nullified because of the collisions. On an average, it will move with a velocity called drift velocity. So we can write this formula to calculate the time taken as distance traveled by drift velocity. What is the distance traveled from one end to the other end of the conductor? The conductor length is 3 meters. So L is equal to 3 meters. Here we know a condition for current flowing through a conductor, which is nothing but NEAVD. We will see what are the terms. N number of electrons per unit volume, electron charge, area of cross section, drift velocity. So here the data we have written here, and electron charge we already know 1.602 into 10 to the power of minus 19 coulombs. So with this data we will find what is the time taken. So from this we can write drift velocity is equal to current flowing by NEA, right? So here T, time taken, will be length of the conductor by drift velocity. So length, drift velocity we know here L by I by NEA. So this implies LNEA by current. So this is the time, we are calculating the time of an electron to travel from one end to the other end of a conductor. L is nothing but 3 meters. N, number of electrons per unit volume, 8.5 into 10 to the power of 28. So electron charge is, we know, 1.6 into 10 to the power of minus 19. Area of cross section already given, 2 into 10 to the power of minus 6, and here the current flowing is nothing but 3 amperes. So here time, you can calculate the time in this way. So if you calculate this one and simplify the terms here, you will get the time taken value as T is equal to, in simplification we need to simplify the powers of the 10 and t is equal to 2.72 into 10 to the power of 4 seconds. 2.72 into 10 to the power of 4 seconds. So time will always come in seconds, and if you want to calculate the time in hours, it will come around as 7 hours 33 minutes. This will be coming around 7 hours 33 minutes. In either way you can take. If you want to take in seconds, this is the answer. We won't take it in hours. So it is in seconds. That means if you divide this by 60, you will get it in minutes. Then again, if you divide by 60, you will get it in hours. So this is the way to calculate the time taken of an electron. So we will move to the next problem. Now we will see the next problem. A storage battery of EMF 8 volts and internal resistance 0.5 ohms is being charged by 120 volts DC supply using a series resistor of 15.5 ohms. What is the terminal voltage of the battery during charging? So here we will see some batteries which after getting discharged we use it to charge them. So how here doing also means 8 volts battery which is having an internal resistance. Even though if it is a battery, it must have an internal resistance, just like a material or conductor has a resistance of some value. So here the battery is also having some internal resistance, and it is connected in series with a resistor of 15.5 ohms. Generally we connect the resistors in the circuits in series or parallel depending on the current flow. What kind of current flow, how much current flow we need to get in the circuit, depending on that current requirement we actually connect the resistors in series or parallel. Here a resistor is connected in series. So what is the effective EMF? The 120 volts DC supply is charging 8 volts battery, storage battery. So effective EMF in the circuit will be 120 volts minus 8 volts, that will be 112 volts. 120 minus effective means if the battery is connected to this much, this must be subtracted with the voltage we are supplying. So what is the current flowing in the circuit? Current flowing in circuit. So this is equal to effective EMF by resistance, total resistance across the circuit. So this value will come as 112 by 0.5, which is internal resistance of the battery, and 15.5, which is external resistance connected in series with the battery in the circuit. Current flowing will be here 112 by this will come as 16, and this will be 7 amperes. Current flowing in the circuit. Now what is the question here? What is the terminal voltage of the battery during charging? Obviously the terminal voltage, terminal means the battery will have two terminals, positive and negative. 8 volts is the potential difference across its two terminals. While it is being charged by 120 volts DC supply, the terminal voltage obviously will increase. So how much it will increase? So the terminal voltage V is equal to E plus I R. R is internal resistance of the battery, I current flowing through the circuit, E means the voltage of the storage battery. Here the effective terminal voltage will be 8 plus current flowing is nothing but 7 amperes into internal resistance of the storage battery is 0.5. So here 8 plus 3.5, this will be coming around 11.5 voltage. Obviously if you are charging a battery more than the potential difference of the battery, so obviously the terminal voltage will increase, it will be more than the original voltage of the battery. So this is the way to calculate the terminal voltage by using this formula. So we will end this video with these 5 problems, and in the next session we will take another topic and we will be doing some JEE problems on that topic.